Well, now let's talk about solving a logarithmic equation. An equation in logarithmic form. How exciting. Well, let's see what we got. So we got log base 9 of x equals 3/2. Well, one of the techniques that we can use if we're solving a logarithmic equation, we can just use the definition of a logarithm. And let's see, if we think about that, then I know that this is the base, 9 is the base, this is the exponent, and that's the answer. And in this case, the answer is x. That's what we're trying to solve for. How neat is that? So log base 9 of x. Well, let's put that in exponential form. So we can say that x is equal to 9 raised to the power of 3/2. And I included this other because this is the way your book shows it. We could simplify that 9 and say, okay, this 9 is 3 squared, and we can raising 3 squared to the power of 3 over 2. And if I do, I can see that this, and of course, when we're raising an exponent to a power, we multiply the exponents. But my 2 and my 2 would just cancel out and actually leave me with 3 cubed. And if I'm doing it without the aid of a calculator, that certainly is probably easier to deal with than taking 9 and then taking the square root of 9 and then cubing it. But that's in essence what we just did when we simplify it. So we can either work with it as 9 raised to the power of 3/2 or the square root of 9 cubed, or we could simplify it a bit and just say, hey, this is going to be equal 3 cubed. And again, I wrote that in both forms. X is equal to the square root of 9 cubed or just 3 cubed, depending on how I want to simplify it and solve it, which means that x is going to equal, are you ready? 27. And so if I think about that in log again, and you put that back into the log, it would be log base 9 of 27 equals 3/2. So in this case, x equals 27. Now I feel compelled that we should do one more. And I know that you are eagerly awaiting that. And so I don't want to let you down. So let's look at this one. We got log base 16 of x equals 5/2. And again, I'm going to put this in exponential form where my base is 16, my exponent is 5 over 2, and we're solving for x, which is the answer there in our logarithmic form. So we rewrite that so it's where x is equal to 16 raised to the power of 5 over 2, or we're talking about square root of 16 raised to the 5th power. And again, I put that where we could simplify it. And if we do, if I got 2 raised to the 4th power, and I'm multiplying those exponents, 4 times 5/2, I can do a little simplification here, 2, and then 2 times 5, and I can say, well, that's the same thing as 2 to the 10th power. And here we just write that out, where x is equal to this either, depending on how you want to solve it, the square root of 16 to the 5th power, or 2 raised to the 10th power. And then that would mean that x is equal to, either way I try to figure it, and you can do it both ways. You can even put it in your calculator, 16 raised to the 5th, 5 over 2 power, just straight in like that, and I believe you're going to get 1024. And if you don't, then just go blame Joey Bag of Donuts, because he probably did something wrong. Solving a logarithmic equation. Now, one thing that's important, and this doesn't come up in this case, I can't take the log of a negative number, but we're going to see that in our next example coming up. Try to hold your excitement down.